All right, hi. My name is Tony Berard. I've made a new mathematical discovery, so we're going to go through it. I was a math tutor at my local community college for over 20 years, so I know a lot about math. I got a bachelor's degree in math from Lawrence Technological University. I graduated with the highest honors possible, summa cum laude, and I got a 3.93. So no, it wasn't a 4.0, but pretty darn close. I wrote a math book, actually a few. They're on Amazon.com if you want to look me up. My name is Tony Berard. So I guess I'll write that to start with. So if you want to Google me, you can find me. I don't know if you can find me with Google. If you go into Amazon.com and type in my name, you might find me. But the name of my book is it's Points, Lines, and Conic Sections. And the subtitle is A Sequel to College Algebra. So yeah, it's a sequel to college algebra. I don't know why that's way over there. My camera's over there. I must have it flipped. But the text is right. I don't know. Sometimes figuring out this technology is really, really troublesome. All right. So in that book, you will have a lot of stuff about the conic sections. So I will tell you what you need to know, although I should get my glasses. This is going to be a little bit of a long video anyway, so just bear with me, please. Don't scroll away. I'm going to show you something great. I just need my glasses. I keep reading on the interactions and stuff on YouTube that people are scrolling. They're looking for dopamine hits and they don't want any deep dives. But that's not totally true, because I do see a number of the math channels that are doing quite well. All right. So if we have this ellipse, so let's see, we'll draw it this way. So this distance here is A, and this distance here is B. Okay, so then we have equations for it. If it's centered at the origin, 0, 0, it's x squared over a squared plus y squared over b squared is equal to 1. So you'll get this in any algebra book, which, you know, I won't say that's wrong. It's not, but I'm going to improve upon it. Good thing I got 3 boards. I watched a video of this lady at Harvard giving some lecture on manifold theory and stuff like that. Way over my head. So this is something much easier for you to see. It's coming down the mountain a lot, but it's still a brand new discovery. All right, so from that ellipse, we have a relationship. Well, I guess I should say more things. So let's go back to here. There's 2 foci at C and minus C, where C squared is equal to A squared minus B squared. B cannot get larger than A. I think the hyperbola is a plus there. Hopefully I have that right. I didn't look that part up. But anyway, c is going to be here. So if we choose a squared to be, let's say, 16 and 9. So if b squared is 9, which is 3, normally your Pythagorean hypotenuse would be 25. But we're not going to get that here. But for a hyperbola, we would. We're going to get 16 minus 9, which is 7. So this will be the square root of 7, which is 2 point something. 2 point. Can't be 3 because that's 9. So it has to be 2 point something. And if this is 4, 2 point something is kind of in far. So it can't be plus because it's going to be 5. 16 squared plus 9 is 25. 5. So it has to be right. It's going to be 2.7 or something, which is more than half the way there. It's going to be somewhere about there, I guess. So that's negative c and c. I guess c will be about here. Maybe I had it right. All right, I did that to be able to draw a line through the focus. So this will track down to, if we use mx plus b, this slope is m. M equals something, we'll get to there in a moment. All right, and there'll be a distance d. Let's say this is our intersection point, P2. This is our intersection point, P1. And the distance across will be d. And then we'll have two focal chord pieces, D1 and D2. All right, that's what I needed to show you to go to the new stuff that I have. So here's my mathematical discovery. So let me see if I can do this without my glasses. So 1 over D1 plus 1 over D2 in an ellipse is equal to a constant, which I determined was 2a over b squared in my book. So, given that that's true, we have a formula for b squared. That's the term under the y. So b squared is equal to, this is in my book, 2a d1 d2 divided by d1 plus d2. And the slope in my book is given as, and I actually derived these in the book. It's astounding. So m is equal to plus or minus the square root of b squared, that's this, times 2a minus d, all over a times ad minus 2b squared. All right, can you see that? Guess I should be there. I don't know if you can see that now. So it's 1 over d1 plus 1 over d2 is equal to 2a over b squared. That's the constant. Then b squared is given as that. M is given as that. All right, so then if we square both sides of this slope formula, and then we insert b squared into it and we simplify, That's going to be a truckload of algebra. I'm not going to, you can try that on your own. But when you're all done, you're going to get this. The slope is equal to plus or minus 1 over the absolute value of d2 minus d1 times the square root of 2 times d1 d2. This is my new discovery here. This is pretty cool. 2 minus d1 plus d2 over a. Alright, look at that guy. Isn't that a beauty? It's not even that complicated. I mean, if you've seen some complicated math formulas, you'll know what I'm saying. It's not complicated. Make sure everything's right. My computer's over there, so I have to watch the screen way over there. But my station is over here. All right, so this part here is a discriminant. You know, in the quadratic formula, I did a video on that just recently. Given ax squared plus bx plus c is equal to 0, I showed you in that video the solution is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, underneath that radical is b squared minus 4ac. That is known as the discriminant. And we know we need to know certain things about that discriminant because we're taking a square root. And if you got something negative under that square root, you just landed in imaginary number land. And so we need to watch the discriminant. Well, we have a discriminant right here. It doesn't look anything like the quadratic formula discriminant. This is my new discovery. I just discovered this today. So you can't get any more breaking news than this. It's not even an hour old, and already I'm making a video on it. And yes, I did not make this discovery totally on my own. In my math book, I assumed that there wasn't a formula possible. I didn't have enough skill, apparently, to go through it. But with Gemini, my buddy Gemini over there, me and Gemini working together figured it out. I had to give Gemini the correct prompts, and it chugged through the math for me. So it did this. So I can't claim total original authorship, but me and an AI collaborator figured this out. So this is pretty cool. All right, so this discriminant is broken up into two parts. We're going to call this the product. Oh, the point of all this is, can we, given this, find values of A, B, D1, D2, D, and what else? M, all being rational, every single one of them. That's the goal. Is it possible? Yes, it is. We're going to do it. All right, so we're going to break this discriminant down into two parts. 2d1 d2 times this big parentheses 2 minus d1 plus d2 over a. So this part we're going to call P for product. Not to be confused with P1 and P2 for the points on the ellipse. This is just P. And then this part, I called it the bubble when I was talking with Gemini, so it used the letter B. So product and bubble. There's a relationship between the product and the bubble. And so now we get a four-step process. So step one is you get to pick any rational numbers you like for D1 and D2. So pick rational D1 and D2. Okay. Right there. All right, step two, since that's easy to do, you compute the sum. Compute, I'll use S for sum, and it's equal to D1 plus D2. The next step is, you also have to compute the product D1, D2. So comma, P equals D1, D2. I was able to squeeze it in there, still legible. All right, then step three is you choose a perfect square, k squared. 3, choose k squared less than or equal to 4p. If this were 0, then that would be 2. And then 2 times 2 is 4, and that's p. So, seems like that should be greater than 4p. But it says less than 4p, so I'm going to assume I wrote it down right. Then next is you compute b. This is brand new. So I mean, if I have a little kink in here, I'm sorry. Then we compute A is S over 2 minus B. And this is the A on the ellipse. And it's equal to S over 2 minus B. This B is the bubble, not B as in B squared. This is a capital B. So I'm trying to keep all my letters distinct. All right, that's the procedure. So we are going to use this procedure. I chose D1 as 3 and D2 as 7. I'm going to keep this, and I'm going to go to, I guess, this first one. So get my book, Points, Lines, and Conic Sections, please. It's took me 10 years to write that. That was before the age of AI. All right, so we're going to let D1 equal 3 and D2 equal to 7. So the sum S is equal to 10. 3 plus 7 is 10. And the product P is 21. 3 times 7 is 21. So then next we're going to compute B. No, we have to choose a k squared. So I chose k squared. All right, so 4p was 4 times 21, which was 84. That's what it was. And so I chose a k squared less than that of 81. So you have to choose a perfect square. And it can be a rational perfect square, like 81 over 16 or 81 over 49, you know. You can do that. I chose just a simple 81, keeping it in the integers. So choose k squared equal 81, which is less than 4p, and 4p is equal to 4 times 21, which is 84. So I chose one that was less than 84 because the procedure said to choose it less than 4p. So I was wrong that it was not greater than. It was less than. All right. Oh, all right. Then the next step is to compute A. So I can compute A or M. So let's do A. So A is going to be equal to S over 2 minus B. S is the sum 10. 2 minus B. Did I do B? I didn't do B yet. So we have to compute B. We'll do it here. B is equal to k squared over 2p. I have that in my other notes. No, I didn't. B is 2 minus d1 over d1 plus d2 over A. So B is also equal to k squared over 2p. For some reason. Oh, that was in the procedure that Gemini developed. So that's a shortcut formula that we're going to use. Although I write it down. K squared less than 4p. Actually, that got into some rather... there was another quadratic equation that developed. It was a Diophantine equation, which was part of number theory. So I guess I will leave that part of it out. It wasn't that bad, but you would need more than just a small amount of algebra to understand it, I think, because I had a little bit of trouble with it. So we'll just, you could compute this. Let's not do this then, because that's assuming a Diophantine equation. Let's do it with the stuff we have. So B is 2 minus d1 plus d2 over A. 2 minus d1 plus d2 over A. 2 minus d1 plus d2 is 10. A I need B to get A, and I need A to get B. Isn't that hilarious? Yeah, Gemini's pretty smart. Well, we're going to have to use his formula. So it's k squared over 2p. K squared we chose to be 81, and 2 times the product of 21. So the 2 times 21 is 42. So 81 over 42. So that's B. So 81 over 42. All right, let's multiply top and bottom by 42. 42 is the answer to life, the universe, and everything. Shows up here. Little plug for Douglas Adams. He was a British author, deceased quite a while now. So 420 over 2 times 42 is 84. Minus, and the 42's cancel, leaving 81. There's also why you need k squared to be less than, showing up right there. So this is 420 over 3. 3 goes into 42 14 times, so 140. So A is 140. Then B squared,
I
guess I didn't need that. B squared is equal to 2A is 140, times D1, D2, that's the product, which is 21, divided by D1 plus D2, that's the sum of 10. 10 goes into 140 10 times. So B squared is 2 times 14, which is 28, times 21. 1 is nice, gives us 28. 0 and 2 times 8 is 16. Carry the 1, 4, 5. 8, 588. So B squared is 588. So A squared would be 140 squared. What else do I need? A slope? Let's find the slope. So the slope going through the focus will be, I've got that right here. So it's equal to plus or minus square root of B squared, which is 588 squared, times 2A minus D. 2 times A is 140, times D. D, do I have D yet? Oh, D is the sum. So S is D, which is 10. Divided by A times AD minus 2B squared. A is 140 times AD, 140 times D, D is 10, minus 2B squared. 2 times B, B squared is 588. We don't square it because it's already been squared. So there's our slope. A little messy. This is minus. So 2 times 140 is 280, minus 10 is 270. Parenthesis. A 10 goes into here and into here. What else we got? 14 is 2 times 7. There might have been another way to compute this without getting lost in all these numbers. Yes, Gemini gave me another formula. Let's use that one. M is equal to plus or minus 1 over absolute value of D1 minus D2 times the root of k squared. Isn't that easier? So we get plus or minus 1 divided by d2 minus d1 would be 7 minus 3, which is 4. Absolute value of 4. Even if I had switched it, I would have got negative 4. Absolute value, which is 4. K squared was 81. So it's 9. So it's plus or minus 9/4. So this reduces to 9/4. So you are going to get a perfect square, but you'd have to crunch some numbers. So hope you'll forgive my little indulgence there. All right. So we've got that. The slope is also equal to plus or minus 1 over d2 minus d1, absolute value. Can you see both? No, you can't. All right. So the slope is also equal to this. So if you took this big discriminant I had here, which was p times b, once we found p and b, p was 21 and b was 81 over 42. The 42 would go into the 21, so that's where this easier one is coming from. So that one I can kind of see. And so then we need to calculate d. So I write d down. I don't see it. So I had an equation from the book. So d is equal to 2ab squared times m squared plus 1. This is something I did figure out a long time ago. B squared plus a squared m squared. So we got all these values. We're supposed to get 10, right? d1 plus d2 is 3 plus 7. This is also supposed to get you this. So let's see if we can get there. 2 times a is 140, 140, times b squared, which is 588, times m squared, that's going to be 81 over 16, plus 1, divided by b squared, which is 588, plus a squared, which is 140, squared. In the top, it's just a single power, but in the bottom, it's squared, times m squared, which is 81 over 16. So I have fractions within fractions, so I'm going to multiply top and bottom by 16. So that's going to make a 16 appear here and cancel here. I have a sum, so you have to distribute the 16. Once it's been distributed, I'll knock it off. Then, if you distribute this times this, and then the 16 will cancel that. So I only need to distribute the 16 to inside this parentheses. So I'll distribute it, but then I have to multiply by 16 to distribute it. So the 16 will cancel and it get multiplied here because there's no denominator to cancel it. So there. So 81 plus 16 is 97. So this parentheses becomes 97. So let us I can take a 16 out of everything. 16 out of here leaves that. 16 is 2 times 2. And I get a 16 times 5. That's only 90. Or no, I only need to get a... There's a 4 in here. The last two digits are a multiple of 4. So I'll take 4 out of here and 2 out of here. So 2 out of here is going to leave 70. So that's 2 and 2. I need 2 more 2s. So a 4 needs to come out of here. 4 will go into 5 one time, leaving a remainder of 1. You can do long division right on a number here. So 4 goes into 18 4 times, which is 16, remainder 2. So 4 goes into 28 7 times. So 147. And then I need to take a 16 out of here. Then notice there was another 2 that could have came out. So this is 140 times 140 times 81. There, so now I can eliminate that. So I need to take a 16 out of here. So that means I need to take a 4 out of here, which leaves a 35. And then a 35. So we'd have to multiply 35 times 35 times 81, add 588 to that, and multiply 70 times 147 times 97. I did that in my scratch work. So you're going to get 99. I'm going to cheat slightly again. So it's equal to 99,813. And on the top it's going to be 99,8130. So this cancels, leaving 10. That was supposed to be our distance. So it all worked. So anyway, that's my new discovery. I'll show it one more time for the camera, and I'll put a box around it. This is my big honking discovery. There's a matching one for the hyperbola. It's got a plus sign there. That's the only difference. So could have had a plus sign here too, I can't remember. But there was very, very minor difference in the two. The structure was nearly identical. So yeah, look at that discriminant. And there's a 4-part, 5-part procedure to break down that. I use the term with Gemini, domesticate it. So, because it's got 3 variables. 3 variables. You can choose them all. So, but in the procedure, you don't choose A itself. You choose you choose a k squared, and that is equivalent to choosing your A in the grand scheme of things. So, and there's a hidden Diophantine equation I didn't show you because it's slightly complex. So, but yeah, if you have AI, you could just click the video link, feed it to AI, and ask it to analyze it for you, and it'll give you all this, just like I got it. So, anyway, please like and share and subscribe. Have a great day.